In question 1a, we're asked to describe the difference between longitudinal and transverse waves. Well, longitudinal waves have oscillations parallel to the direction of energy transfer. Transverse waves have oscillations perpendicular to the direction of energy transfer. In B, part 1, we have an oscilloscope trace and we're asked to determine the amplitude of the signal displayed. Well, the amplitude is maximum displacement in the vertical direction from the equilibrium, and we're told each division has a value of 10 millivolts. The wave is going 4 divisions above and below equilibrium, so that is 4 times 10 millivolts, which is 40 millivolts. In part 2, we're asked to find the frequency of the sound. Well, first we can find the time period. Here we have 3 divisions, and we're told each division is 0.50 milliseconds, and that is 1.50 milliseconds for the time period. Frequency is 1 over time period, which is 1 over 1.50 times 10 to the minus 3, and that comes out at 670 Hertz. In part 3, we're told the speed of sound in air is 330 meters per second and asked to find the wavelength, which is speed over frequency, which is 330 over 670, giving 0.49 meters. In C, we're told the output from the loudspeaker is adjusted to give a quarter of the original intensity. We're asked to describe and explain how the displayed signal will be different. Okay, well, intensity is proportional to the square of amplitude. So if amplitude is halved to 20 millivolts, the intensity will be 1 over a half squared, which is a quarter of the original.